Hello everyone and good holy. I am unique number 19, Iron Joy H. Fernandez, and I will be your teacher in educational statistics. Today, we are going to discuss a new topic, and that topic is representing frequency distribution using histogram, frequency polygon, and cumulative frequency polygon. This topic aims to define frequency distribution, histogram, frequency polygon, and cumulative frequency polygon, and represent frequency distribution graphically using histogram, frequency polygon, and cumulative frequency polygon. Before we start, let me ask this question. What is frequency distribution? A frequency distribution is a representation either in a graphical or tabular format that displays the number of observations within a given interval. The interval size depends on the data being analyzed and the goals of the analyst. Frequency distributions are typically used within a statistical context. Generally, it can be associated with the charting of a normal distribution. Frequency distributions are portrayed as frequency tables, histograms, or polygons. Now that we have already defined the frequency distribution, let's try to take a look on how to represent the frequency distribution graphically using histogram, frequency polygon, and cumulative frequency polygon. Let's start with histogram. What is histogram? A histogram is a graphical representation of tabulated frequencies. It consists of contiguous boxes and has both a horizontal and a vertical axis. The horizontal axis is labeled with what the data represents. For instance, the distance from your home to school. The vertical axis is labeled either frequency or relative frequency. It is different from the vertical bar graph and it has no gaps between the bars. The histogram can give you the shape of the data, the center, and the spread of the data. The relative frequency is equal to the frequency for an observed value of the data divided by the total number of the data values in the sample. If f is equal to frequency, n is the total number of data values or the sum of the individual frequencies, and rf is the relative frequency, then rf or relative frequency is equal to f divided by n. For example, if 3 students in Mr. Ahab's English class of 40 students receive from 90% to 100%, then f is equal to 3, n is equal to 40, and rf is equal to f over n equals 3 over 40 equals 0.075. 7.5% of the students receive 90 to 100%. 90 to 100% are quantitative measures. Now, how to construct a histogram? To construct a histogram, first decide how many bars of intervals, also called classes, represent the data. Many histograms consist of 5 to 15 bars or classes for clarity. The number of bars needs to be chosen. Now, let's draw a histogram to illustrate the data. The lengths of 30 plant leaves of species A were measured and the information grouped as shown. Measurements were taken correct to the nearest centimeter. The first thing we're gonna do is to draw an x and y axis. Next, we'll need to label the zeros, which is gonna be where the x and y axis meet. Now we need to label both of these axes. The y-axis is going to be the frequency or the amount of data points in each class. Now, if you look at the table, the largest number in the frequency column is 12 for the third class. So knowing this, we can draw this line and mark it as 12 somewhere near the top of our y-axis ends. Then we're gonna mark 10, 8, 6, 4, and 2 on the y-axis. The x-axis is going to represent the length of the leaf. Consecutive bars in the histogram touch one another. So before we label the x-axis, we need to calculate the class boundaries for each class. We can't use the class limits because technically, there would be a gap between the bars. Since our data are all whole numbers, we can simply subtract 0.5 from the lower limits of each class and add 0.5 to the upper limits of each class. So the boundaries for class 1 will be 10 minus 0.5, which equals 9.5 at the lower boundary, and 14 plus 0.5, which equals 14.5 as the upper boundary. Now we'll do this for the rest of the remaining classes as you see here in this table. Now that we have the class boundaries, we can label the x-axis. We can start by marking the value of the lower class boundary of class 1 somewhere to the right of our 0. So 9.5 here, and then the upper class value of 14.5 off to the right. Next, we need to mark the class boundaries for class 2 on the x-axis. Since the upper boundary of class 1 and the lower boundary of class 2 are the same, that value is already been marked. So we then mark 19.5, which is the upper boundary for class 2, then 24.5, the upper boundary for class 3, the 29.5 for the upper boundary of class 4. After that, we have to mark our frequency above the class boundaries. So for class 1, we have 3 in respect to the y-axis values. Then we can draw in our lines for the first bar and fill it in. Next, mark the frequency for class 2, which is 8 in respect to the y-axis, and draw in the line and fill in the bar. For class 3, the frequency is 12, so again mark it and draw in the line and fill in the bar. And continue this for the class 4. Once you're finished, you can put the frequency values above the bars as this gives you a quicker way to view the histogram. This is the finished graph of the frequency distribution using the histogram. Now, let's proceed to the representation of frequency distribution using frequency polygon. What is frequency polygon? Frequency polygon is a graphical device for understanding the shapes of distributions. They serve the same purpose as histograms but are specially helpful for comparing sets of data. It uses a line that connects the frequencies of the classes at the midpoints of the classes. For example, the scores of 642 students on a psychology test. The test consists of 197 items, each graded as correct or incorrect. The students' scores range from 46 to 167. Now let's construct the frequency polygon using the table 1 or the frequency distribution of psychology test scores. The first thing we're gonna do is to draw an x and y axis. Next, we'll need to label the zeros, which is gonna be where the x and y axis meet. Now we need to label both of these axes. The y-axis is going to be the frequency. Now if you look at the table, the largest number in the frequency column is 147 for the 6th class. So knowing this, we can assign a number greater than 147. Let's say 160, then mark it as 160. Then we're gonna mark 140, 120, 100, 80, 60, 40, and 20 on the y-axis. For the x-axis, we need to calculate the class mark for each of the class. The formula for finding the class mark of a class is the lower limit plus the upper limit, take the result, and divided by 2. So for class 1, we have the lower limit 29.5 plus the upper limit 39.5. Take the result and divide by 2, we get 34.5. For the class 2, we have the lower limit 39.5 plus the upper limit 49.5. Take the result and divide by 2, we get 44.5. Continuing this process for the remaining classes, we get 54.5, 64.5, 74.5, and so on. Now that we have class midpoints, we can label the x-axis. Next, we need to plot the points for each of the classes. We're gonna use the midpoints as the x-axis and the frequencies for the y-axis. For the class 1, we have a frequency of 0 and a class midpoint of 34.5. Find this value on the graph where these two values intersect and then plot using a dot. For the class 2, we have frequency of 3 and a class midpoint of 44.5. Again, mark the point of intersection with a dot and continue this process for the remaining classes. Now that we have our points plotted, we'll connect the dots from class 1 to class 2 to class 3 and so on until we have all the points connected. And this is the finished graph of the frequency distribution using frequency polygon. Now, let's proceed to the last part of our lesson, which is the representation of frequency distribution using cumulative frequency polygon. What is cumulative frequency polygon? Cumulative frequency polygon is sometimes called ogive. It is a type of frequency polygon that shows cumulative frequency. A cumulative frequency polygon graph plots cumulative frequency on the y-axis and class boundaries along the x-axis. How to construct a cumulative frequency polygon? Example, draw cumulative frequency polygon graph for the following set of data. The first step is to make a relative frequency table from the data. The first column has the class limits, the second column has the frequency, and the third column has the relative frequency. Then, add a fourth column and cumulate the frequencies in column 2 going down from top to bottom. For example, the second entry is the sum of the first row and the second row in the frequency column. 5 plus 5 equals 10. And the third entry is the sum of the first, second, and third row in the frequency column. 5 plus 5 plus 6 equals 16. Continuing this process for the remaining classes, we get 17, 17, and 25. Next, add a fifth column and cumulate the relative frequencies from column 3. For the first row, we have 0.2. For the second entry is the sum of the first row and the second row in the relative frequency column. 0.20 plus 0.20, we get 0.40. And the third entry is the sum of the first, the second, and third row in the relative frequency column, 0.64. If you do this step correctly, your values should add up to 100% or 1 as a decimal. Next step is to draw a Cartesian plane with percent cumulative relative frequency on the y-axis. Mark the x-axis with the class boundaries. Plot your points. Note that each point should be plotted on the upper limit of the class boundary. Now, we're ready to plot the points on the graph starting with the lower class limit for the class 1. The lower limit of class 1 is 1, which has a percent cumulative relative frequency or y value of 0. Next is the upper class boundary of class 1, 9 in the x-axis, where we have a percent cumulative relative frequency of 0.20 or 20%. So we find our point of intersection, x is equal to 9 and y is equal to 0.20 or 20%. Plot the point and proceed to the next upper class limit. For the upper class limit of class 2, we have 19 and our percent cumulative relative frequency or y value is 0.40 or 40%. Find the point of intersection and plot the next point. If we continue this process for the remaining classes, we get these points. Now that we have all our points plotted, we will connect the dots from 0 value to class 1 to class 2 to class 3 and so on until we have all the points connected. Finally, this is the finished graph for the data using the cumulative frequency polygon. And that ends our lesson. Hopefully you've learned something out of this video. I am unique number 19, Iron Joy H. Fernandez. Thank you for watching. Keep safe and good holy.